Our topic was all about rockets, and we had a lot of questions inside of it, and some of them were, how does a rocket engine work? Why does a rocket work? What are the different types of rockets? What are the different elements of rockets? How does NASA use rockets, and how will NASA use rockets in the future? And we also wanted to know about the history of rockets. So now we'll talk a little more in depth about each of those questions.
Our first question was, how does a rocket work? So I'm going to tell you about that. Like most engines, rockets burn fuel. Most rocket engines turn the fuel into hot gas. The engine pushes the gas out its back, and then the gas makes the rocket move forward. A rocket is different from a jet engine. A jet engine needs air to work. A rocket engine doesn't need air. It carries with it everything it needs. A rocket engine works in space where there is no air. There are two main types of rocket engines. Some rockets use liquid fuel. The main engines on the space shuttle Orbiter use liquid fuel. The Russian Soyuz use liquid fuel. Other rockets use solid fuel. On the side of the space shuttle, there are two white rocket boosters. They use solid fuels. Fireworks and metal rockets also fly using solid fuels.
Our next question was, why does a rocket work? In space, an engine has nothing to push against. So how do rockets move there? Rockets work by a scientific rule called Newton's third law of motion. English scientist Sir Isaac Newton listed 3 laws of motion. He did this more than 300 years ago. His third law says that for every action, there is an equal and opposite reaction. The rocket pushes on its exhaust. The exhaust pushes the rocket too. The rocket pushes the exhaust backwards. The exhaust makes the rocket move forward. This rule can be seen on Earth. Imagine a person standing on a skateboard. Imagine that the person is throwing a bowling ball. The ball will go forward. The person on the skateboard will move too. The person will move backwards. Because the person is heavier, the bowling ball will move farther. Rockets also follow Newton's third law of motion. When the rocket pushes the exhaust out the bottom, the equal and opposite reaction is that the rocket will move upward.
Our next question is, how does NASA use rockets? Early NASA missions used rockets built by the military. Alan Shepard was the first American in space. He flew the U.S. Army's Redstone rocket. John Glenn was the first American in orbit. He flew the Atlas rocket. NASA's Germany missions used the Titan II rocket. The first rockets NASA built to launch astronauts were the Saturn IB, and the Saturn V. These rockets were used for the Apollo missions. The Apollo mission sent men to the moon. A Saturn V also launched the Skylab space station. The space shuttle uses rocket engines. NASA uses rockets to launch satellites. It also uses rockets to send probes to other worlds. These rockets include Atlas V, the Delta II, the Pegasus, and the Taurus. NASA uses smaller sounding rockets for scientific research. These rockets go up and come back down. They do not fly into orbit. Our next question was, how does NASA use rockets? Early NASA missions used rockets built by the military. Alan Shepard was the first American in space. He flew on the U.S. Army's Redstone rocket. John Glenn was the first American in orbit. He flew the Atlas rocket. NASA's Germany missions used the Titan II rocket. The first rockets NASA built to launch astronauts were the Saturn I, the Saturn IB, and the Saturn V. These rockets were used for Apollo missions. The Apollo missions sent men to the moon. A Saturn V also launched the Skylab space station. The space shuttle uses rocket engines. NASA uses rockets to launch satellites. It also uses rockets to send probes to other worlds. These rockets include the Atlas V, the Delta II, the Pegasus, and the Taurus. NASA uses smaller sounding rockets for scientific research. These rockets go up and down and come back. They go up and come back down. They do not fly into orbit.
The next question is, how will NASA use rockets in the future? New rockets are being developed today. They will launch astronauts on future missions. The new rockets will not look like the space shuttle. These rockets will look more like earlier ones. They will be tall and round and thin. These rockets will take astronauts into space. They will also take supplies to the International Space Station. NASA is also working on a powerful new rocket called the Heavy Lift Vehicle. This rocket will be able to take big loads into space. Together, these new rockets will make it possible to explore other worlds. Someday, they will try to send humans to Mars. Alright, now I'm going to show some pictures of more stuff about rockets. This is an air rocket. You've probably seen these before. The way they work is you step on the pump and air goes through the tube and it will propel the rocket upward. Now, air rockets do not actually qualify as real rockets, and the reason why is because real rockets propel themselves upward by using fuel that they push out the bottom and propels the rocket upward, and air rockets are propelled upward by the air coming out of the tube, so they do not qualify as actual rockets.
So these are just some types of different rockets.
This picture shows how big the Saturn V rocket actually is when it's laid down, and you can see it's very big.
This is another picture of a rocket, and you can see how big it is compared to people.
This picture shows the building that they store the rockets in, and next to it is the Saturn V rocket being towed to the launch pad.
This is a picture of a rocket compared to a car.
This is just a cool picture of the space shuttle in the middle of its launch.
This is a picture of a rocket after it still has its boosters on it.
This is a picture of the Saturn V rocket just beginning to launch.
This is a picture of the rocket engine.
This is a picture of the Saturn V rocket ready to launch in the nighttime.
This is also another picture of a rocket in the nighttime that is launching.
This picture is of the Saturn V rocket in the middle of its launch.
This is another picture of a rocket, obviously USA rocket. So, yep.
And those are the pictures we have. We also have a few more coming up in a minute. Alright, so this is a picture of the space shuttle launching. I actually took this picture when I went to Cape Canaveral, Florida a few years ago and saw this in person. It was very cool because it makes a lot of noise, and even from 7 miles away is the closest anyone can watch from. I think I watched it from around at least 12 miles away. But this is an up-close picture of the space shuttle in flight. I have one more here for you. This one is a picture of the same space shuttle from Cape Canaveral, Florida. Zoomed out a little bit. Up there in the middle of the top of your screen is the space shuttle. Again, this is a really cool picture, I think, because it's taken from about 12 miles away, and it shows the space shuttle in the middle of its launch. So these are from the space shuttle launch that I saw in person, and they are real pictures. Alright, so now we're going to show you some of our props. and some of the space shuttle models. This is the space shuttle. Kind of works like this. Like we said before, it blasts off like this from an upright position, and once the fuel is burned from the boosters and the fuel tank, that drops off at a high altitude, and the space shuttle continues to go up, and it lands just like this, like an airplane. Here, I'll show you a smaller model. Just lands like an airplane. Space shuttles bring stuff to space, such as the Hubble Space Telescope that you've probably heard about. It takes pictures of space objects from space. It has these little solar panels on it. That's how it's powered. That is stored in this section of the space shuttle, right there. That opens up. It also brings parts of space stations. This is one of them. Looks like a space station. Also has solar panels on the side to power it. Now I have a rocket. This one is the rocket that goes to the moon. Blasts off like that. And in this one, only the stages drop off just like a space shuttle. This one drops out first, and then this one. And then eventually, once you get to the moon, there's only these two stages. And all that comes home is this little top white part, and it lands in the ocean. When it gets to the moon, it flies like this. When it gets to the moon, out of that top part, comes this thing, and this is the thing that actually lands on the moon. It comes down like this, and it has rockets on the side of it, so it can slow it down. It lands, and the people get out. The astronaut. They are called astronauts. They come down the side of it, and they explore the moon. 2 of them come out. I actually have 3 of them right here, but only 2 come out, and 1 stays in the rocket. And when they're ready, they collect samples from the moon and do a lot of scientific research on the moon. And when they're ready to come back, they get back in the rocket, and only this part blasts off. That part stays on the moon and acts as like a launch pad. This part goes up and comes back to the top part of the rocket, which I don't have just that right now, but it comes back into that top part of the rocket and docks with it, and people get out, and then this thing goes back into space, and all that comes back is that top little capsule, and it will land in the ocean, and then the people will get picked up by a boat, and that's how the rocket works. So I just have another space shuttle right here. Anyway, that's all our props and our models of rockets, and so anyway, that's our rockets.
Goodbye.
That's the end of our video, and thanks for watching.